Hello student, myself Nimesh Prabhakar. Welcome to Antenna and Propagation lecture series. In my previous lecture, we discussed about the antenna array. Now, in this lecture, we will discuss first about the horizontal lambda by 2 antenna above ground plane. Then next we discuss about the W8JK antenna above ground plane. And last we discussed about the vertical antenna above ground plane. So in this lecture we will discuss about these three antenna. So now first of all we start with the horizontal lambda by 2 antenna above plain ground. See, this is the figure for the horizontal lambda by 2 antenna. The analysis of horizontal lambda by 2 antenna above plane ground can be analyzed using method of image. So here we use the method of image to analyze this antenna, in which the ground can be replaced with the image of antenna placed above the ground with same distance below the ground plane. So here in the first one figure we can see this is the antenna we have placed below the ground plane. So this is the original and this is the image of the antenna. Consider the horizontal antenna of length lambda by 2 at height above ground plane. So this is the antenna height h is the lambda by 2 above the ground plane. Let us consider the image of the horizontal antenna at the distance h below the ground plane as shown in the figure. So this is the original antenna and below this is the image of this antenna. For the perfectly conducting ground, the tangential component of E is 0. So to have the tangential component of E0, the reflected wave goes under the phase reversal of 180 degree at the point of ground surface. The resultant electric field at the distance point P is vector sum of the direct wave and the reflective wave as shown in the figure. So here in the second figure we can see this is the directed wave and this is the reflected wave, and at the point P this is the sum of the directed wave and reflected wave. Now we discuss about the driving point impedance and the radiation resistance of the horizontal lambda by 2 antenna. The expression for the voltage at a driving point of antenna is given by V1 is equals to Z11 I1 plus Zm plus I2. So here in this equation, this Z11 is indicate the self impedance, Zm is indicate the mutual impedance, Im is indicate the current in the antenna A, and I2 is indicate the current in the antenna A image. Two currents are equal in magnitude but out of phase by 180 degree to satisfy the boundary condition. So here the two currents are out of phase, so we can write the I2 is equals to minus I1. Hence the driving point voltage is given by, so the driving point voltage equation is also changed. So instead of the I2, here we write the I1. So V1 Z11 I1 plus Zm minus I2. So we can write the I1 is the common. So we can write the equation as Z11 minus Zm, and the I1 is the common. Thus the driving point voltage is given by, so we have equation Z1 is equals to V1 upon I1. So we have the equation V1 is equals to Z11 minus Zm into I1 and upon I1. So I1 is cut. So driving point impedance we get the Z11 minus Zm. The real part of the driving point impedance is nothing but the driving point radiation resistance. Now radiation resistance. The radiation resistance of antenna is given by R1 is equals to R11 minus Rn. The driving point resistance is the function of height h above a perfectly conducting ground. So, as the height increases, the effect of an image antenna on the radiation resistance decreases, and thus the radiation resistance approaches the value of the lambda by 2 antenna in free space, that means 73 ohm. The variation of radiation resistance at center of the lambda by 2 antenna as a function of height h is shown in the figure. So here we can see this is the radiation resistance variation. Now the gain of horizontal lambda by 2 antenna. So generally the horizontal lambda by 2 antenna above ground at the height is analyzed by comparing it with the horizontal lambda by 2 antenna in a free space with the same power input. At the greater distance, the gain in the field intensity of the half wavelength antenna above ground, that means Whag, with respect to the half wavelength antenna in a free space is given by the HF, that means Hwag upon Hwfs is equals to under root of R11 plus R1 loss upon R11 plus R1 loss minus Rn into 2 sin HR into sin alpha. So here the R11 indicate the self resistance of the half wavelength antenna. Same as R1 loss is indicate the loss resistance of the half wavelength antenna. Then Rm is indicate the mutual resistance of half wavelength antenna and its image located at the distance 2h. So here the HR we can write as a HR is equal to 2 pi by lambda into the h. Now the field intensity of horizontal lambda by 2 antenna. So the field pattern of the half wavelength horizontal antenna can be plotted as a function of azimuth angle phi for the constant elevation angle alpha. When we rotate a vector from origin to the distance point P, it gives cone as shown in the figure. So here we can see the field radiation pattern of the half horizontal lambda by 2 antenna. Consider XY plane with horizontal as shown in the figure. From the figure, the spherical right triangle, we can write from the figure we can write the triangle we can see here. The cos phi is equals to cos phi into cos alpha. And the equation 1 can be written as, we can also write this equation number 1 by using a trigonometric identity. Sin phi dash is equals to under root of 1 minus cos square phi into cos square alpha. Now to obtain the field intensity, we can use the expression for the pattern as, so we can write the field intensity like a E plan, that means E alpha phi is equals to cos pi by 2 cos phi cos alpha upon under root 1 minus cos square alpha. Now we can write the relative field pattern of the horizontal lambda by 2 dipole antenna in the free space as fixed elevation angle alpha 0 is given by E phi is equals to cos pi by 2 cos phi cos alpha 0 upon under root 1 minus cos square phi cos square alpha 0. So if the antenna is placed at the height h above the perfectly conducting ground using expression number 3, we can multiply it by the pattern of two isotropic point source. For isotropic source, the pattern is given by E isotropic, that means for the E for the isotropic antenna is sin HR sin alpha, where the HR, that means is indicate the height of the antenna above ground. Thus, the three-dimensional field pattern of a horizontal lambda by 2 dipole antenna can be obtained by multiplying equation number 2 and equation number 5. So we get the E is equals to E alpha phi is equals to cos pi by 2, cos phi cos alpha upon under root 1 minus cos square phi cos square alpha into sin HR sin alpha. Now, the second one type of antenna is the W8JK antenna above plain ground. Two horizontal lambda by 2 elements are placed very close to each other with current in two elements are out of phase. The antenna is called W8JK antenna. Two elements of the length lambda by 2 carrying equal magnitude but out of phase current are placed above perfect conducting ground at height h with distance d of the separation between two elements as shown in the figure. So here two antenna we have placed at the distance of the d, and the separation between that distance is d. Now, the gain in the field intensity of W8JK antenna is given by GF, that means gain is equals to under root of R11 plus R1 loss upon 2R11 plus R1 loss plus R14 minus R12 minus R12 into 1 minus 1 upon dr cos alpha minus 1 upon 2hr sin alpha plus 1 upon dr cos alpha plus 2hr sin alpha. Here this dr is nothing but the distance of the separation between the element, and we can write in terms of the wavelength as a 2 pi d upon lambda. And hr is the height of the element of the above ground plane, and it is nothing but the 2 pi h upon lambda. And R11 is the self resistance of a single element. Same as R12 is indicate the mutual resistance of the element 1 and 2. R13 is indicate the mutual resistance of element 1 and 3. And R14 is same as indicate the mutual resistance of element 1 and 4. Consider a W8JK antenna with two lambda by 2 elements placed lambda by 8 apart from each other as shown in this figure. For the W8JK antenna, the pattern for height 0.5 lambda and 0.75 lambda are shown in this figure. For comparison purpose, for the single lambda by 2 element, the pattern for the same height above ground and the same power input are represented with the dash curve. So here this dash curve is represented. Now, when the plane of W8JK antenna is tilted by the angle 8, then the field intensity of antenna increase with the large elevation angle and the field intensity decrease with the lower elevation angle. The angle of which the plane of W8JK antenna is tilted is called the tilt angle as shown in this figure. Now we discuss about the last one type of antenna of this lecture is the vertical antenna above plain ground. Vertical stub antenna with a length L placed above a perfectly conducting ground of infinite extent is shown in this figure. As shown in the figure, the ground may be replaced by image antenna of length L. So here the ground we have replaced with the image of the antenna with the length L. This type of antenna is very much similar to the center field linear antenna with a symmetrical current distribution. Hence, the electric field intensity is a function of elevation angle alpha and the distance r at which distant point P is located, and the expression is given by E alpha r is equal to 60 upon r under root P upon R11 plus R1 loss cos IR sin alpha minus cos R upon cos alpha, and the unit is V by M. So here this R11 is indicate the self resistance of stub at the maximum current, and the R1 loss is indicate the effective loss resistance at the same point, that means point of maximum current. The variation of radiation resistance, that means self resistance of antenna, is shown in this figure. The vertical stub antenna are most widely used for the AM broadcasting purpose. So this is the application of the vertical antenna, that means vertical stub antenna are mostly used in the AM amplitude modulation broadcasting purpose. So in this lecture we have discussed three antenna. First we discussed about the horizontal λ/2 antenna above plane ground. Then we discussed about the W8JK antenna above plane ground. And last we discussed about the vertical antenna above plane ground. Thank you.